Assalamu alaikum. In this video, I will explain to you how to simplify a circuit. Sometimes you are asked to find R total, or you need to simplify the circuit to find R total. This is a simple series parallel circuit. And as you see, I label the circuit. In order to simplify the circuit, I will use two models. This is the first circuit model, which is a series model, just R1 and R2 series. If they are in series, node to node connected, so the equivalent resistance equals R1 plus R2. If the two resistors are connected in parallel, so this is the equivalent resistance. To be more general, the series branch could be more than two resistors. All of them will be added, and the parallel branch, the same thing as we discussed in a previous video. Now, if you look at this circuit doesn't have any of the series branches. There are actually, but maybe it is not clear to all of us at this time. But we have one parallel branch similar to this one. R1 and R2 here is connected between node A and B, so they are connected to the same node. If you look at R2 and R4, both of them are connected across node 2 and node 3. There is similarity between this circuit, model circuit, with our circuit we try to modify. What I will do, I will replace these two resistors with an equivalent single resistor connected between node 2 and node 3, and I will remove these two resistors, replace them actually, so the circuit becomes as drawn here. R1, R3 kept intact, but R2 and R4 are replaced by their equivalent resistance connected between 2 and 3. I want to look at a more difficult circuit to solve, so I will look at this circuit, and I will do the same thing. I'll start by labeling the node. If you look at 3 and 5, you will notice 3 and 5 are series because they are like a string, like our module in the previous slides. If you look at R7, R8 and R9, and this is the node, and that is another node, all of them are connected between the same node, so these two resistors are parallel. If you check these two, you will see again R1 and R11 are connected between two nodes, both of them connected across the same node. This is our circuit with the node labeled appeared, and here what I have done previously. So we have 1, 2, 3, 4. I will call R3 and R2 are equivalent 0, And then, as you see, we have here R equivalent 0 with R4 in parallel. So I will replace these two resistors with a single resistor, which is the equivalent resistance, parallel resistor of R4 and R equivalent 0. This is R equivalent 1. As you see, it is R1 parallel with R12. R equivalent 3 is R7, R8, and R9 in parallel. I will replace these two resistors with a single resistor, equivalent resistance. I will replace these two resistors with another equivalent resistor here, and I will replace these three with an equivalent resistor and look at the circuit and see what I can simplify more. And as you see, here is R1, here is R3, R2. When you check R2, R equivalent to R6 and R equivalent 3, you see they are connected in series, one after the other. So I will replace this one complete R2, R equivalent to R6, R3 with an equivalent resistance, single series equivalent resistance. So the circuit become simplified as you see it. R equivalent 1, here R equivalent 4. We don't have any two resistors in series, but we have 1, 2 in parallel. Since they share the same node, so R equivalent 4 are in parallel with R11. Redraw the circuit. So you have R equivalent 1, R equivalent 5, and R10 connected, all of them in series. And this way you simplify the circuit, and we are done with example number 1. I will see you in the next video.